So here's another practice problem for finding tangents to polars. So the question is, what is the slope of the tangent line at theta equals pi over 4 for the equation r equals 1 plus 2 cosine 3 theta? So here's a graph of r equals 1 plus 2 cosine 3 theta. We have 3 petals and 3 little petals inside of them. It's a pretty cool graph. And here's again our equation for finding the tangent line. And now we're going to have to use this whole equation and pretty much just plug in our r and our dr d theta. So we know what r is. It's written up here. So I'm going to go ahead and solve for dr d theta. 1, the derivative of 1 is just going to be 0. And the derivative of 2 cosine 3 theta, that's going to be cosine turns into negative sine, and the chain rule multiplies the 3 out, so we're going to get a negative 6 sine of 3 theta. And now pretty much we're just going to plug in our dr d theta and our r into this equation. So let's see how that looks like. And we're going to plug in the theta equals pi over 4. So let's see how that looks like. So dy dx is equal to, so dr d theta is negative 6 sine of 3 theta times sine theta plus our r, which is going to be 1 plus 2 cosine 3 theta times cosine theta. Alright, now we're going to divide all of that by, well, we have another negative 6 sine 3 theta times cosine theta minus our r times sine of theta. So now what we need to do is pretty much multiply this out. And some of these problems, they might not look nice at the end. You're gonna have a lot of messy algebra to do. So let's see what this turns into. Well, the beginning part is fine. Sine 3 theta times sine of theta plus, well, we get a cosine theta, and then we get a 2 cosine 3 theta times cosine theta. Divide all that by negative 6 sine 3 theta times the cosine theta minus, well, we get a sine theta, negative sine theta, and distribute the negative sign, we get a negative 2 cosine 3 theta times sine theta. So yeah, it doesn't look that nice, but now all we have to do is plug in theta equals pi over 4, and we just have a bunch of sines and cosines, so that's going to give us a real answer. And you guys can do that on the calculator. It might take you a while, but I got that dy dx is approximately 1.216. So let's go ahead and think about that for a bit. Where is pi over 4 on this graph? Well, we're starting here. We're coming around to this little loop, and I guess somewhere around this area is going to be our value of the polar graph at theta equals pi over 4. And we're saying that the tangent, the slope of the tangent line, is positive and a bit above 1, and I guess that'll make sense. That'll be somewhere over here, because we do have a tangent slope that's positive, and I guess you could see it as being greater than 1. So there's another problem where you have to find the tangent, just that this time we're given a theta value, and we actually need to solve for the tangent to solve for the dy dx. In the previous video, you were given dy dx and you had to solve for theta, so this is a different type of problem using the same concept.